The world's largest iceberg is spinning in an ocean vortex with no end in sight for months. A gargantuan iceberg has been slowly spinning in one spot in the Southern Ocean, and it could continue to stay trapped in this vortex for quite some time, experts say. As the world's largest iceberg, the colossus A3A is of great interest to scientists who have closely monitored the frozen block since it calved from Antarctica's Filchner-Ronne ice shelf in 1986. Now, the iceberg's fate is unclear as it remains stuck as a result of a rare set of circumstances that scientists say is unprecedented. This has never happened before as far as we all know, said Dr. Les Waddling, a professor emeritus of life sciences with the University of Hawaii at Manoa, in an email. The roughly 3,672 square kilometer, 1,418 square mile chunk of ice slightly bigger than Rhode Island and more than twice the size of the city of London, drifted over a seamount and got stuck in a phenomenon known as a Taylor column, a spinning vortex of water caused by ocean currents hitting the underwater mountain. The currents create a cylindrical motion of the water above the seamount, where the iceberg now floats, rotating about 15 degrees a day, according to the British Antarctic Survey. The curiously spinning berg is slowly melting, but won't impact rising sea levels, experts say, and instead highlights the fascinating life cycle of icebergs and how the climate crisis impacts Antarctic ice sheets. A jumbo iceberg, currents, and an underwater mountain. When the floating mass initially broke off from the ice shelf in the 80s, it didn't get far before grounding on the bottom of the Weddell Sea, melting in place for over 3 decades. It eventually loosened enough in 2020 to start a gradual drift toward the world's greatest ocean current system, the Antarctic Circumpolar Current. But when the iceberg reached the current in the spring, instead of being sent into the slightly warmer waters of the South Atlantic Ocean, its journey was halted once more. The frozen block is slowly rotating above an underwater mountain named Peary Bank Seamount, which is about 1,000 meters (3,280 feet) tall. The iceberg, which measures about 61 by 59 kilometers (about 37.9 by 36.7 miles), is slightly smaller than the mountain, and is at that sweet spot in size, where it's retained by the column, but it doesn't stick out of the column too much. So, it doesn't get pushed away very easily, said Dr. Alexander Burley, a physical oceanographer with British Antarctic Survey. The research institute noticed the peculiar spin when satellite imagery revealed the iceberg stuck in one spot near the South Orkney Islands, Burley said. Because the spin is so slow, it's not visible when looking at the berg in real time. We have studied these Taylor columns in the past, not specifically to do with icebergs, but because they're really kind of cute, interesting oceanographic phenomena which have important implications for ocean circulation, Burley said. The thing about them is they tend to be quite small. So, the seamount that it's currently over is only about 100 kilometers (62 miles) across and is quite a small target. It had to get into the small area to get entrained within the column, so it is surprising. We don't know how common it is, because we've not really looked, but it's super interesting from an oceanographic perspective. The conditions of the Taylor column had to be just right to grab the massive iceberg, Waddling said. Generally, Taylor columns are formed when there is a balance of the moving water with the size and shape of the seamount, he explained. If the water is moving too fast relative to the size of the seamount, vortices of spinning water are shed downstream of the seamount. If the water is not moving fast enough, then the water passes around and over the seamount with some small turbulence on the downstream side, he added via email. A giant spinning iceberg is not a concern as long as the spinning iceberg remains entrapped. It will melt more slowly than it would have had it continued on its journey. No matter where the ice melts, it will not contribute to rising sea levels, as the iceberg is already in the water, Burley said. Calving of ice shelves along the Antarctic coastline is also a natural part of Earth's process, and there is nothing to be immediately concerned about with any individual iceberg calving, Burley said. What is of concern particularly around West Antarctica is increasingly thinning ice shelves amid the climate crisis, which can cause more iceberg calving and result in land-based ice melting faster, thus contributing to rising sea levels, he added. I don't think we should be worried about this particular event. But more generally, we should be interested in icebergs, understanding numbers, where they're coming from, and ultimately what that means for the land-based ice that sits behind them, and the stability of that going into the future, Burley said. How long is this spin cycle? While researchers do not know how long the iceberg will continue to spin, Burley pointed to a January 2015 study from British Antarctic Survey researchers that found a profiling float, an oceanographic instrument used for taking surface measurements, had remained in a Taylor column for 4 years. Because the float was about the size of a person and is drastically smaller than the giant iceberg, the researchers do not expect the iceberg to stay in the column as long, Burley said. It's likely that some combination of wind variations, currents, and the exact configuration of the berg relative to the column will move it out. But I think we're sort of surprised that it's been in for as long as it has, so I guess we wait to see, he added. Because of the large size of the seamount, the iceberg could remain spinning for a long time, even years, said Dr. Tony Koslow, a research oceanographer emeritus with the Scripps Institution of Oceanography at the University of California, San Diego. The size of the seamount is critical. Peary is very large, thus its ability to trap the iceberg for years, he said in an email. But the phenomenon itself is nothing to be concerned about, according to Koslow. Seamounts are known for being hot spots for ocean biodiversity, as the currents that flow around the mounds create ideal conditions for invertebrates that attach themselves to the mountain and other fauna that feed on food particles swept around by the currents, Koslow told CNN in previous reporting. The melting of the iceberg could affect these natural conditions, but more research is needed to know for sure, Waddling said. I suppose it could cause some reduction of biodiversity in the water column, but may have a small effect on the benthic community's marine organisms that live on the seafloor. This iceberg is large enough to interfere with the additional primary production diatoms, like algae, that is produced as the nutrient-rich water that upwells in the Taylor column feeds the phytoplankton. If that happens, then food supply to the bottom will be diminished, Waddling said via email. However, he added, I don't see any reason to be concerned. It sure is neat, though, and demonstrates again what an interesting world we live in.